Hi guys, welcome to another video. In this video, it's a part of a series where I'm going through how to sketch cubic functions and kind of an introduction to cubic functions in general. So the last video was a bit of a longer one. I'm talking about how to sketch it by first finding your intercepts and you're trying to find what happens to the graph, what's the nature of the graph, what does it look like. So that's what we're going to actually do in this one again, and the only difference here is that you're given something called a repeated bracket. In other words, it's going to look like that. So we're going to see if we can break it down again. I've actually got my steps there using my little arrows here to actually help me out, or help you out in fact, so that way hopefully this is a bit easier. Okay, so without using a class pad or a graphic calculator, sketch a graph of the cubic function y equals 2x plus 1, x take 5 squared. Okay, so let's try find my x-intercept. So remember, x-intercepts is when you let y equals 0. X-intercepts is when you let x equals 0. Okay, so let's find my x-intercepts first. Let y equals 0. So 0 is equal to 2. Oops, I've kind of gone off the page there. 0 is equal to 2x plus 1, x take 5 squared. Now don't worry about this 2. This 2 can be basically divided out on both sides. That cancels out. This 0 divided by 2 is still 0. So actually we just get rid of it. We don't even have to worry about it. Just worry about the brackets. Now you might be wondering, oh, what do I do with this squared part here? What do I do? I actually just expand it and show you what it looks like. I actually just rewrite it twice, because essentially x take 5 is basically x take 5 squared. So I'm just going to write it out in full. Using the null factor law, I'm going to find out what my roots are going to be. So x equals -1, x equals 5, x equals 5. So these roots are the same, so they're just a double up. Don't worry about that last one there. So in this case, this tells me I've got 2 roots. And more specifically, if you saw in my first video that I had in the series, that this one that's been squared is the one where it touches the x-axis. It doesn't go through it, it just touches the x-axis. Really important to know, and I'll show you that later on. Okay, let's look at my y-intercepts. So my y-intercepts is when I let x equal 0. Y equals, let's have a look, 2, 0 plus 1, 0 take 5 squared. So I've got 2 times by 1. Now -5 squared is just 25. So 25 times by 2 is 50. So that's my y-intercept there. So I'm just running out my coordinates now for what I've been given. Okay, so I've done this bit, I've done this bit. Now let's see what happens to the graph as x gets increasingly large, positively and negatively. So as x gets closer to infinity, so as long as it gets bigger and bigger and bigger, so towards 1,000, 1,000,000, a bajillion, I don't know. As soon as it gets bigger, what happens to my graph? What does y end up equaling? So in my rule here, if I let x equal big numbers like 1,000,000, your y value is also going to be really, really big. It says x approaches infinity, y approaches infinity. And you can really tell from this because of this 2. This 2 is a positive 2, so it tells you it's going to go in this direction. So when you're graphing, essentially this feature is important to tell you whether or not your graph's going to look like that or like that. And in this case, it's going up like that in this direction, because if you think about your quadrant as x approaches infinity, y approaches infinity. So it's going to go in this direction here. So it's going to look like this. And let's just make sure it's true. It says x approaches -infinity, it gets really, really small. When you put negative numbers in, really big negative numbers in there, you're going to have a negative times by a negative, which makes a positive, and your positive, so you're going to end up having a really, really small, because essentially you're going to have here, sorry, I probably should have looked over here. If you look here, you're going to have a negative number times by a negative, which is positive. Positive times by a negative is a negative, and a negative times by that 2, which is positive, it's going to be negative. So it's actually going to get smaller. So the idea is that if that a value, or that thing, that number is in front of the brackets, if that is positive, you're going to have a graph that looks like this. If you have a value that is negative, it's going to look like that. Okay? So, we've got all the information we need. Let's actually sketch it. I'm going to do a different color. Let's use green. Okay. Very rough sketch. So, I'm going to have my, I'm going to put my intercept in. Intercept's up here. 50, I'm going to have my two roots, my -1. I might put over a bit more space. And then I'm going to have 5. Now, again, it doesn't have to be to scale, it's just a sketch. Now, as mentioned here, as x approaches infinity, so does y, so it goes this way. As x approaches -infinity, y goes to -infinity, so it goes that way. Now, remember when I mentioned earlier, I've got this bit here? This is where it just touches the x-axis. So here, it's not going to go like that. That's not what it's going to look like. It's just going to go above, and it's going to be like a turning point there. Okay? Everything else can be approximate. So I'm just going to take a little stab in the dark here. I'm going to just guess it looks something like that. Okay? Now you can have various interpretations on this. It could look slightly different again. I might want to draw it where I've got a really high turning point like that. It's really up to you, as long as you've gone through those points and that it's just touching when the x-intercept here where it's 5. Okay, as long as it's just touching, that's where you should be. Okay, so sorry about my terrible diagram. It's a bit hard to draw here, but I hope you really understand these steps. These are the main steps that you have to take to be able to sketch a graph.